this video, we're going to be talking about Chapter 1 in our stats book. And this isn't going to work. There we go. Okay, so these are the learning objectives in Chapter 1. You can go through the PowerPoint on your own so that you can see what we'll be looking at through this chapter. I think you'll find that this chapter isn't as difficult as it looks. Okay, so the first thing we're going to look at, what is statistics? So statistics is basically a branch of mathematics. A lot of you already knew that coming into it. Some of you came in with a little bit of a fear of math, and so I want to just ask you to put that fear aside. Some of you might even be excited about statistics, and I'm right there with you. But if you are a little bit afraid of math, this is a bit of a different type of math. We focus on organizing, analyzing, and interpreting numbers instead of the calculating numbers. And in behavioral and social science, especially in psychology, we use statistical methods all the time. When we do our research, we have to use statistics to make sense of the numbers. And so this little visual that I created here, statistics is basically part of what makes our scientific method work. So we observe a thing, we wonder what it means or what causes it, we make an intuitive guess, and then we observe again. Well, statistics allows us to document that whole process, and then when we observe again and we document it again, we can see whether or not what we're observing makes any sense. And so that's really what we're trying to do with statistics, and we'll be learning about that this semester. There are two different kinds of statistics. Descriptive statistics are the kinds that you hear about a lot. They summarize and describe a group of numbers from a research study. You hear them a lot with averages and means and medians and modes, and we'll be talking about those in these first couple of chapters. And then we have inferential statistics, and that's where you draw inferences, where you infer information from data. So you draw conclusions based on the scores you collected in a research study, but it's not just based on the people that you studied. You draw inferences about a larger group of people, or a larger group of animals, or a larger group of carrots if you're studying carrots. So those are the kinds of things you want to draw conclusions based on a broader population than just the small sample that you are studying. And so inferential statistics is where we will get to later in the semester. Oops, did I skip one? Yes, okay. So let's look at some of the basic concepts. A variable. Most of you should have already taken algebra. Maybe it was a while ago. So let's just talk about a variable. We're not talking about just x's and y's. We're talking about characteristics or conditions that can have different values. So in psychology, we talk about variables all the time. So it could be the level of stress that a person is in. When we're looking at an experiment, we might look at the levels of stress for different conditions in an experiment. Different variables that can certainly change the outcome for your study could be the age of the individual, the gender, or religion. If you're looking at attitudes, for example, and you're trying to see how different attitudes are different with different groups, then you would certainly want to look at the different variables of those different groups. And so you might have different attitudes for people who are over 65 compared with those who are 18 to 25. And those would be variables. Now, those ages would be their values. So the possible number or category that a score is the value. So most often they're numbers when we're talking about numerical values, but sometimes the values are categories. So for gender, the values are male, female, and then there are others. For religion, it could be Catholic, Christian, Buddhist, Methodist, lots of different values there. So value is the possible number or category that a score can have. And then the score is a particular person's value for a variable. So my age, my height, my weight, we're not going to talk about that. And those kinds of things, those would be my scores on a larger category or variable. So you might have a current stress level of 5 on a scale of 0 to 10. So these are the different concepts that we use in statistics. I think those are pretty simple. Now, different kinds of variables, I've already sort of mentioned those. So we have numeric variables, or quantitative, if you want to use the bigger words. We also have categorical variables or nominal variables. Nominal is just another way to say categorical. So the numerical variables, quantitative, those are the variables that are, the values are numbers. So equal interval would be the variables that have the, they're like on a number range, like on a number line, and there are equal points between the numbers, like a grade point average. It could also be an age or weight. Think of things that have a scale that would be on a number line type of thing. And then you also have a rank order, and those are not necessarily equal in between them, but they just are the order that things come in. So it could be the order that people came in a race. It could be the grade that they are in their class. You know, like they're standing in their class if they are valedictorian, or first or second or third in their class. So those kinds of things. So rank order is a different type of quantitative variable. So it could be a number. Then you have the categorical variables, sometimes called qualitative variables. That won't be on the test, but they're variables that have values that are names or categories. So what is your college major, or your religion, gender, that kind of thing. Okay. Oops. Let's not do that. There we go. Okay, so levels of measurement. The levels of measurement make a difference in the types of statistics we do with them. So different procedures are used for each kind of variable. So for the equal interval variables, we use the differences of values that correspond to the differences of the underlying thing being measured. So for example, your pain level, we would presume then that your pain level, if you have a 2 of pain on a scale of 1 to 10, that if you had a pain level of 4, that it would be twice as bad as the pain at level 2. If your stress level at level 5, on a scale of 1 to 10 or 0 to 10, if you have a stress level of level 5, that's not as bad as level 10 of stress level. So those are equal interval, like we were saying with weight and age and those kinds of things. But with rank order, they just are relative position, and so you wouldn't want to use addition and subtraction, because those are more of they almost become like a category than just a number. So the class standing, you might be 9th in your class, but if there are only 10 people in your class, then that's not as great as being 9th in your class if there are 900 people in your class. Do you see how there's a difference? So it's relative. It's not an exact thing. And then nominal, like we said, are just categories. Okay. So let's look, here's a table. This actually is in your book. And so sometimes if you want to take notes, depending on how you are a note taker, this PowerPoint will be available to you in the class as well in eCampus. And if you want to use this when you're taking your quizzes, you are certainly able to do that. Let's look at frequency. So here's the thing. This first chapter, we're not just talking about how we think about numbers. We also want to talk about how we show numbers and how we talk about numbers. And so when we're looking at data, we look for the patterns in the numbers. So we look at how often the numbers show up, so the frequency, and we look at the number of scores for a particular value. So if we ask a group of people how many siblings they have, we could get this table of this frequency table to the right. And you can see in this table that we asked people how many siblings they have, and the majority of people here have 2 siblings. We could even create a table like this to show our frequencies, and this is one of the simplest ways to show your data. No calculating involved. Does that make sense? Okay. So let's make a frequency table of your own. You could make a frequency table of anything. I recently made a frequency table of temperatures for Grand Prairie, Texas, because that's where I live, for the year of 2019. So you list each possible value from lowest to highest. You go one by one through the scores, and you make a mark by each next to the value on the list. And as you go through your list, you're making like a tally mark. Make a table showing how many times each value on your list was used. And you figure the percentages of scores for each value. So I'm going to show you how we did this. Here's an example. So here is a research study using a happiness scale ranging from 0, not at all happy, to 10, extremely happy. So you see the happiness ratings are lined up top to bottom from 0 to 10. And then these are our scores. We have all of these scores here, and we put our frequency tally on our frequency table, and these are just tally marks. Do you see how you just like tally them up? Just as if you were to write them down, you just tally them up. So there's an 8, so you put a tally by 8, and there's a 2, you can put 1 by 2. And actually when I do these, I actually mark them. Let me grab the little pen here with a little red, and I would mark through the 8, there, and then through the 2, and then through the 3. Do you see how that goes? So I would be doing this by hand. This is how we used to do it in the olden days. So here's my frequency tally. Okay, so I get all the way down. I have my last 3, dun, 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 and here is my tally sheet. Okay, done. Now I count them. See? Once I have my tallies here, I count them out. There they are. And then I calculate the percent. So to figure the percent, what you do is you have the frequency of each value. And I actually like to put these into an Excel spreadsheet. That's my preference, is to put them in an Excel spreadsheet so that it calculates it for me. But you already know how many people are in here, and you can count them up. And you divide each of these by the number that you have, and then multiply it by 100. So here we have 2, 5, 9, 12, 15, 16, 17, 18, 19, 20. So we have 20 people. So 2 out of 20 is 10%, 3 out of 20 is 15%. See what I mean? And so these are the percentages, and here we have the majority of people have a happiness rating of 3. Does that make sense? Okay. Now here's another example. This is a horn honking study. We are going to look at interpersonal hostility measured as a delay in seconds, so the number of seconds it takes for the person who is in the car to honk his horn at a stalled car after the light has changed to green. Okay, so we measured this in a fictional study for 29 cars, and this is the data that we got. Okay, so 29 cars were stuck at a light behind a stalled car, and they measured from the time the light turned green until the guy honked the horn, how long it took them in seconds. Okay, all right, so just kind of looking through this, it's hard to tell when you look at it like this, right? But here's one who was very impatient, 0 seconds, followed by a guy who was pretty patient. It looks like he was the most patient of them. Isn't that funny? One, no patience at all. Here's most patient was 5 seconds. Okay, so let's look at our data in a frequency table. Delay in seconds from 0 to 5 seconds. We have a frequency of 1, 1, 1, 2, 3, 4, 5, 6. Most people will write in here. We've already got the percentages calculated. Okay. And here's another example. Let me go back to that just real quick so we can talk about it. So here we have the percentages. So we have the ones here. So there's only 3, maybe 3.5%. We get up to 20. So 20%. These are even, I don't know, we could even group these up. what would happen if we grouped them up? That's something to think about, isn't it? So here's another type of frequency table. Now this is for categorical. Those frequency tables that we just did were for numerical things, but these are for just majors, okay? So this is just asking people what their major is, and we had a frequency of 5 psychology majors, 8 sociology majors, 3 anthropology majors, and 4 political science majors, and these are the percentages of this. And I don't know, I really think people would pick psychology, but that's just me. So there we go. So it's just another way to do a frequency table. All right, now, grouped frequency tables. This is a little bit different. So I was showing you how you might group the honked data together. So think about that. A frequency table that uses intervals of values instead of just the each independent value. So you list the number of participants of each interval of values. If the list of possible values ranges from 0 to 10, a possible set of intervals might be 0 to 1, 2 to 3, 3 to 4. You don't want them to overlap. 6 to 7, 8 to 9, 10 to 11, for example. 11 obviously would be 0 because it goes from 0 to 10, but at least you could have something like that. So here's an example. These tables are in your book. So you have a stress rating interval from 0 to 1 up to 10 to 11. Here's another one. They did 0 to 4, 5 to 9. Each range is that number of points goes up to 49, and so it groups them together. It just really depends on how much data you have. If you have a very long table with a lot of individual numbers, it might be easier to do it grouped. So if you have too many values, you might use a grouped frequency table. All right, so if we did the horn honking study in a grouped frequency table, we might we might collapse the delay in seconds into intervals 0.0 to 0.9, 1.0 to 1.9, et cetera, down to 5.0 to 5.9. And then we could see that right in here is where we have the majority of people. And you could see definitely 3 to 3.9 seconds is the highest frequency. Okay. Now, using that data, we have a frequency table. Let me go back. I want to show you that. So we have a frequency table, still just numbers. Graphs are better. And one of the graphs that are frequently used to show data are histograms. So we used a frequency table to create a histogram. You might not have used a histogram a lot in your math classes, but we use histograms quite a bit in statistics for psychology, and I'll be showing you a little bit later on when we talk about the normal curve or the bell curve, which you might have heard about before. So the histogram, this is an example of a histogram. The height of each bar here in this example, the height of each bar is the frequency of each value on the table. So here's 2.5, 7.5, 12.5, 17.5, etc. There are the intervals, and the frequencies are here. So this is 0 to 4 is here, 5 to 9 is here. So they just put the average right there. So this is 0 to 4, 5 to 9, 10 to 14. See how that goes? So these are the intervals going across the bottom. These are the frequencies going up the top. They are using just the numbers here and not the percentages, but you can group, you can do this on percentages or by the numbers, depending on which one you are. You just need to be clear if this is the frequency or the frequency percentage. And this is an example that is now also in your textbook. Okay, so let's talk about how to make a histogram. I just kind of explained it, but the book does explain it step by step so that you can make one on your own. You make the frequency table or a grouped frequency table. You put the values at the bottom of the page, so they would go across the bottom. I like using graph paper, of course, because I like to nerd out with my graph paper. So you put the values at the bottom of the page. You make a scale of the frequencies along the left side of the page, with the lower numbers being at the bottom, going up to the top. And then you make a bar for each value so that they look like that. So here we go. We have the horn honking study, the same data that we had before. We have the intervals, 0 to 0.9. Wait. Wait a minute. Why did these get out of order? Interesting. We need to look at that. Okay. Need to double check that, but as you can see, I do need to double check that data because I had not noticed that before. This looks like it, for some reason, pulled this out of order. And so, but you can see how each one, I made this in Excel, and I don't know why this put it out of order for me. And so that would be something you want to check before you publish your data, am I right? But you can see that this is supposed to go across the bottom in your delay in seconds interval. And then I have it with percents going up above. I only go up to 50% because none of these are going to be up to 100%. I could have done just as easily done this with the frequencies instead of the percents. But I am going to go check my data on that one. Okay. Now, what if I wanted to do a bar graph with categorical variables? On those, we do not connect them. Notice how with the histograms, they are connected. See how these are connected? With a bar chart, whoops, let me go one more. With a bar graph, they are not connected because these are not connected. Your family member, so this is of the closest person in your life. We just, let's say that we do a survey, we just ask people, just name the closest person in your life. And they say a family member, a non-romantic friend, a romantic partner, or other, okay? This is asking 208 people at this college. And you leave space between them because these are not connected categories. They are just categories. So there are about 33% said family member, no, not percent, frequency. 33 of the 208 said family member. 70, maybe 75 said non-romantic friend. About 90 something said romantic partner. And about 5 people said other. So this is a histogram for categorical variables, and you leave a space between the bars. Now here's the thing. The reason it's important that we do a frequency distribution like this is so that we can look at the shape that it makes, because the shape of the distribution tells us something about the population that we're talking about. And it tells us about the data. So we learn something not just from the numbers, but from the shape of the frequency distribution. So here is a unimodal distribution. Unimodal, see how it's got one mode, one lump. Here's one with a bimodal. It has 2 humps, 2 humps right there. Distribution with 2 fairly equal high points. We have a rectangular distribution. It's, I wouldn't call that a rectangle, but it looks approximately. This is when the values have approximately the same frequency. So this could be like the number of students in classes at an elementary school. When you start lining up your elementary school and principals start putting students into classes, they try to make sure all of the classes have the same number of students so that they have the same proportion of students per teacher. And so most of the classes are going to have, say, 24 to 26 students. Some might have 22, some might have 26, but they're all going to be right there in that same range. That would be a rectangular distribution. And then others are going to be multimodal, and this would be when there are 2 or more high points. There might even be 3 or more high points, but a bimodal distribution and is a multimodal distribution. It's just sometimes multimodal could have even 3 or more. They don't happen often though. In fact, most of the time we see unimodal. Okay. We also see some skewed, and we want to talk about the difference between symmetrical and skewed. So we're going through this pretty quickly. I know that the book goes into a lot of detail, but it also doesn't have a lot of pictures, and so I wanted to give you kind of a verbal lecture that goes with it, so it's up to you if you want to listen to this or not. But in psychology, in the social and behavioral sciences, most of the scores we look at are symmetrically distributed. We look at, for example, IQ scores and test scores. But if, let's say, for example, that I give an exam in my intro to psychology class, and the exam, and I look at the averages on the scores on the test, and I look at the curve that comes out of that. And let's say, I'm going to use this pen. So let's say that I have a curve. Here's my bell curve, and here are the A's down here. Here are the F's down here, and here's the average for the class. Okay. So most of the time, you're going to have a curve that looks like a bell. Okay. And the majority of the class are going to be right here at the average. And this is where you have your C grades, okay? And then you have your B grades and your A grades, okay? And then you have your D grades and you have your F grades. And we're going to be talking about the bell curve later on, but this is what we call a normal distribution. This is a symmetrical distribution. And so when the scores are symmetrically distributed, this is a normal curve, okay? So that's what we typically expect to find. When scores on when a distribution is skewed, that means the scores, this hump right here, it might be unimodal, but it is skewed. And so I'm going to change the color on this so that you can see it. So that the average of the class might be down here, so that the majority of the students got an F, or the majority of students got an A. And so this is where the majority got shifted away from the middle so that it's off to the side. So I'm going to show you a little bit more about that. So when you have the mode, let me shift back to the laser pointer, I like that. Okay, when you have the unimodal symmetrical distribution, this is what we call a normal curve. Okay, if it is positively skewed and it is skewed to the right, like this, it's positively skewed. If you have it skewed to the left, it is skewed like this. Now both of these, they all look like icebergs. It's really hard to remember. So there are kind of tricks to remember what each one means. So that's what we call a floor effect and a ceiling effect. A floor effect is when the scores pile towards the lower end of the distribution. So let's look at that again. So here we have the floor effect. This is the floor effect. You like how I'm writing on the board? This is because I don't have a classroom to be with you guys. And so I have to write on the screen. Like how are you doing that? Okay, so this is the floor effect. And over here is the ceiling effect. This is not easy to do. Okay. Ceiling. Okay, so let me go back over here so we can look at the definitions just real quick. So scores pile toward the lower end of the distribution because it is not possible to have a lower score, like the number of children that a person has. You can't have less than 0 number of children. And so, like if we were to look at this, the number of children that people have, you start with 0. More people have 2 or 3 children. And then you get up here and then you have fewer and fewer people having 6 or 7 children. Up here, though, this would be like if I were to give you guys a test on addition and subtraction, for example. that would be a ceiling effect because you guys would all pass that. And so this would be a really high average test. So let's look back at that definition. So a ceiling effect, scores pile toward the upper end of the distribution because it's not possible to have a higher score, but it's a very easy statistics test. And so the highest score you can get on this statistics test or an addition and subtraction statistics test would be a 100. That's the highest score you can get. And if everybody and their brother got a 95 or above, then that's a pretty high test, but you can't get higher than 100, so everybody's piled up there to this negative skew. So let's look back over here. This would be a ceiling effect or negative skewed, and this would be the floor effect or positive skewed. That makes sense? That doesn't mean you did better on the test. This doesn't mean you did worse on the test. So I don't want you to think about it positive and negative like this is better and that's worse, okay? This is a negative skew. I don't know. Let's talk about what we could think about. Negative because I'd have to shift everybody down to get them to where they need to be. This is positive because I'd have to shift everybody up to where they need to be. I believe that's why it's called that way. Because to make everything back to normal, where would they have to go to be shifted? This would have to be shifted positively, and this would have to be shifted negatively. Does that make sense? I always try to find ways to remember these kinds of things. So we have the floor effect because everything's down here towards the bottom, and we have the ceiling effect because everything's up here towards the top. Okay. The last part we want to talk about, and every chapter is going to talk about this. In research articles, when you're reading in psychology, and we're not going to do a lot of that in this class. This is just for later on when you're taking a psychology class and you're reading research articles. We're going to do one in this class later. You need to interpret the shapes of distributions from the verbal descriptions in the research articles. They're not going to chart them for you. I wish that they would. To me, I think it would be much more enjoyable. Sometimes they'll chart them for you when they're doing a presentation, but in the actual article themselves, they don't. We do visually analyze data before we conduct our really complex statistical procedures just to kind of see how things are going. But a lot of times we will just do like a visual for demographics just to show a distribution of things just real quick. But the frequency tables are not the biggest deal. We're going to get to some of the more important things. But like I said, the normal frequency table and the normal distribution is something we'll see all the time in psychology. All right, so here are the summary slides for this chapter. I'm not going to go over the summary because we've just gone over all of these things. If you want to rewatch this video, you are certainly welcome to. And thank you very much. Now, how do I turn this off?